Welcome to The Explainer. If you've ever found yourself wondering exactly how massive organizations manage to keep their data flowing quickly and securely without the whole system just completely crashing down, well, you are definitely in the right place. Today, we're demystifying an absolute cornerstone of network design, network segmentation. Let's learn how to tame the chaos.
To kick things off, let's just think about a fundamental question. Why does a large network suddenly become so slow, so noisy, and honestly incredibly difficult to secure? Imagine walking into a giant open-plan office, or maybe a massive classroom, where literally hundreds of people are all trying to shout across the room to each other at the exact same time. There are no walls, no meeting rooms, just one big open space. It would be overwhelmingly loud, right? You absolutely wouldn't be able to get any work done. And worse, if someone walked in who shouldn't be there, they could just wander freely and listen to any private conversation they wanted. Well, a flat, unsegmented computer network operates in that exact same way. It's essentially an open room where every single device is forced to shout over every other device. So, how do we fix it? Well, the solution to all this chaos is actually elegantly simple in theory. We just need to build some walls. Much like putting up soundproof partitions in that noisy office, one physical network has to be divided into smaller, logical parts. By doing this, we immediately start to improve the speed of the network, we lock down our security, and most importantly, we give network administrators their control back.
Here's our roadmap for today. We'll start by looking at the noisy problem of flat networks, then meet our solution, segmentation. We'll compare subnets versus VLANs, cover some real-world examples, weigh the pros and cons, and finally, put your network knowledge to the test.
Okay, part 1, the noisy network problem.
When you let a network get too large without putting any divisions in place, 4 major headaches pop up. First, it just becomes incredibly slow and congested. Second, it gets really noisy. And why is that? Because of unnecessary broadcast traffic. You see, devices are constantly sending out broadcast messages to find other devices or services, and in a flat network, every single device hears every single broadcast. It is literally exhausting for your network hardware. Third, it becomes notoriously difficult to secure. Without internal barriers, if an attacker compromises one simple device, say a cheap smart thermostat, they have a clear, unimpeded runway to move laterally across the network and hit your sensitive servers. And fourth, when something inevitably breaks, it is incredibly hard to monitor and manage simply because the scope of the problem is the entire organization.
Which brings us to part 2, meet network segmentation. Network segmentation is defined simply as breaking one large network into smaller parts so traffic is controlled more effectively. By dividing the network into smaller, bite-sized sections or groups, each specific segment can be managed, monitored, and protected so much more easily. And it's really important to note here that these segments can take a few different forms. They can be physical, they can be logical, or they can be based strictly on IP addressing.
Think of it like taking that giant, noisy pool of devices and organizing them. Instead of one big mess, a router or a layer 3 switch is used to split the network into highly organized, smaller parts. You might set up a specific segment for the sales department, another for engineering, one for finance, and an entirely separate one for guest Wi-Fi. We're grouping devices based on their specific use, their department, or even their physical location. By doing this, the sales team's laptops aren't constantly getting bogged down hearing all the broadcast traffic from the engineering team.
Let's look at how this plays out in a school environment. You typically have a core switch in the middle that branches out. You've got an admin VLAN safely housing the staff, a student VLAN for the noisy classrooms, a completely isolated guest Wi-Fi segment for visitors, and then a highly protected red zone for the actual servers. This kind of logical grouping, that is the absolute foundation of a healthy, functioning network.
So, to boil it all down, organizations segment their networks for 3 major reasons. Number 1 is performance. Making those broadcast domains smaller means way less congestion, which leads to vastly improved response times. Number 2 is security. We isolate our sensitive systems so attackers find it much harder to move laterally. Plus, we can apply highly specific access policies to different groups. And number 3 is management. By organizing by department or service, your resources are allocated effectively. And hey, when a fault happens, and it will, it's contained to a small, easy-to-locate area, rather than bringing down the whole building.
Moving right along to part 3, subnets vs VLANs.
Now, you're going to hear a few terms thrown around together, and while they are heavily related, they are absolutely not identical. Segmenting is just the broad, general concept of dividing a network. It's basically the umbrella term. Subnetting, on the other hand, is the specific method of dividing the actual IP address space, to create smaller IP networks using subnet masks, and that's primarily for routing control. And then we have VLANs, or virtual local area networks, which logically separate traffic at the switch level. VLANs are amazing because they let you separate networks without needing to go out and buy separate physical hardware for every single group in your building.
Let's picture subnetting first. Imagine a master network, say 192.168.1.0/24, being sliced up like a pie. Subnetting divides that one overarching IP network into smaller, distinct subnetworks, subnet 1, subnet 2, and so on. Now, each of these subnets gets its own specific host range and its very own broadcast address. Because they are technically different networks at this point, you absolutely need a router or a layer 3 switch to move traffic between them. This is fantastic for organization and for putting strict limits on where broadcast traffic can actually travel.
Now, contrast that with VLANs. Picture a central switch where sales, engineering, finance, and guest Wi-Fi are all plugged into the exact same physical piece of hardware. But here's the magic. A VLAN logically separates them. It creates entirely separate broadcast domains right there on that shared switch. So devices in VLAN 10 act as if they are completely cut off from devices in VLAN 20, even though their cables are literally plugged in right next to each other. It's incredibly flexible. Just remember, if someone in VLAN 10 actually does need to talk to someone in VLAN 20, that inter-VLAN communication normally requires a router to step in.
Let's dive into Part 4, Real-World Segmentation Examples. Out in the real world, the stakes for proper segmentation are incredibly high. In a school, you absolutely have to isolate the admin offices, which hold all that private student data, from the general student computer labs. In a hospital, the application is quite literally life or death. Medical devices must be segmented entirely away from the public Wi-Fi, and patient record servers have to be tightly controlled so critical, life-saving systems are prioritized over someone streaming a video in the waiting room. In a typical business, you'll almost always see VoIP desk phones placed in their own specific voice VLAN to ensure call quality doesn't drop just because someone down the hall is downloading a massive file. And for smart systems, IoT devices and sensors are heavily isolated. That way, if a cheap, unsecured smart light bulb gets compromised by a hacker, the threat is contained and can't easily jump over to your secure user devices.
Part 5. Advantages and Limitations. Look, as amazing and powerful as segmentation is for network engineers, it is definitely not a magic wand. It requires some careful balancing, and there are very real trade-offs when you actually go to implement it.
On the plus side, the advantages are massive. It drastically improves performance by killing unnecessary traffic, it highly strengthens security by isolating devices, it keeps troubleshooting confined to small areas, and it helps organizations scale up in a way that actually makes sense. But, and there's always a but, the limitations are significant. It adds immediate design complexity. You really have to carefully plan this stuff out because poorly designed rules can accidentally block legitimate, necessary communication. It also adds overhead, requiring extra routing, switch configuration, and constant monitoring. Ultimately, your IT staff has to actually possess the deep technical knowledge required to manage and route traffic across a segmented network without breaking it.
Finally, Part 6, let's test your network knowledge.
Okay, let's put this into practice with a quick scenario. Imagine a college network. It's got student devices, staff laptops, finance computers, printers, and public guest Wi-Fi. And it is all sitting together on one massive flat network. Naturally, during busy periods, the network performance noticeably drops. Furthermore, the college administration is highly concerned that public guest users might somehow be able to access internal private resources.
So, knowing what we know now, how could network segmentation swoop in and improve both performance and security in this specific college scenario? Think back to those logical walls we talked about earlier. How would you divide this whole mess up using subnets or VLANs to solve these issues?
If you're looking at this on an exam or, just trying to fix it in real life, here is the definitive answer. First, you would separate the specific groups. You put the guests, the staff, the finance department, and the printers into entirely different segments or VLANs. By doing this, you instantly reduce the massive waves of broadcast traffic that are causing the congestion, which totally fixes the performance drops during those busy times. And finally, you solve the security nightmare by using routing and security rules to strictly limit access between these new groups. That ensures a guest on their phone absolutely cannot see the finance department servers. Boom, you've restored speed and you've restored security.
To wrap things up, I want to leave you with a bit of a curveball to think about. We know exactly why segmentation is so great, but when might a segmented network actually become more difficult to manage? Think about the overhead, the complex routing rules, and the advanced skills required from your IT team when things get too granular. It's an incredibly powerful tool, but definitely one that demands respect. Thank you so much for joining me on this explainer. Until next time, keep exploring the networks around you.